This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
This is the second lecture on Chapter 2, the CIMA P2 notes, Modern Manufacturing Environment. And you'll see on the next, on the previous page, the end of the previous lecture, I've talked about this idea of continuous improvement, having quality circles where we're always trying to gradually improve the way we operate and the quality. On the next page, there's mention of business process re-engineering, where we fundamentally rethink the whole way we do things, almost start again from scratch. So instead of just this gradual improvement, let's just stop, let's re-examine exactly what we do and see how we can do it better. And it's using information technology to a large degree to help us. That's what's helped make it more popular. But to challenge the way we do everything. And again, I think you've got a zero-based budgeting, a bit after the same style. Relook at everything we do. How can we do it better? How can we improve the way we produce? How can we reduce costs? And so on. And exercise 4 says, identify the key differences between continuous improvement and business process re-engineering. Well, it's whole philosophy of it in that I've just said. It's scrap business process re-engineering. It's scrap what we do at the moment and start again almost. Continuous improvement, just this gradual process. The degree of change, continuous improvement, just little changes each time. Business process re-engineering, a radical change. The time scale, again, this changes completely, this over immediately, so to speak. Here, things change gradually. The level of risk involved. This is much riskier, clearly. Improve gradually, less chance of things going wrong and things always reversible if needed. Business process re-engineering is a much riskier idea. Anyway, let's leave that and let's go on to the very last bit, which is back to arithmetic, calculations. But again, something you should have done before, which is a reminder of throughput accounting. And if you turn to the last page of the chapter, I'm going to go straight into exercise 5. I'm going to use this exercise to remind you what it is and how we approach it. So have a look with me. Pi plc manufactures 2 products A and B. You've got cost cards there, so just running down A, we know the selling price. We've got the cost per unit for materials, labour, other variable costs and fixed costs. They've absorbed the fixed costs. So a full cost of 23 a unit. And because the selling price is 25, the profit of $2. Each unit takes 2 hours to make, still on A, and the maximum demand is 20,000 units. Our problem is that the total hours available for us are 48,000. Because you see, we've 2 products available to us, they're both profitable. And if it weren't for this one problem, we'd produce to meet demand. We'd produce 20,000 of A, 10,000 of B. Obviously, no point in producing any more because we wouldn't sell them. But the problem we've got is if we did produce in full, then A, 20,000 units at 2 hours each would take 40,000 hours. If we were in addition to produce 10,000 Bs, well, at 1 hour each, 10,000, total 50,000. And so I hardly needed to write that down. Our problem is, since we've only got 48,000 hours available, we can't produce A and B in full. The question is, how should we produce? What's our optimum production plan in order to maximise the profit? And we're going to take a throughput approach. And what throughput basically says is that certainly in the short term, all costs really are likely to be fixed other than materials. I'm not saying it's a rule, and it's not always the case, it depends on the product, but certainly for most businesses, labour, for instance, tends to be a fixed cost, because although production may go up and down week by week, usually the workforce stays constant. And all right, some weeks they're more busy, some weeks a bit less busy. But in the short term, labour is more likely to be a fixed cost. Not in the long term. Obviously, in the long term, if we're starting to produce more, we'll hire more people and labour will go up. If production is falling for any reason, then we'll get rid of people and labour will go down. But in the short term, it is more likely that that most of our costs week by week are fixed. And the only cost that's really going to be variable in the short term is materials. If we produce less this week, we need less materials this week. Produce more, we need more. And so that's the underlying assumption behind throughput, that in the short term, the only variable cost is materials. All other costs, we assume in the short term, are fixed. And as a result, think about it. You see, product A, we've yet to decide on our production plan. But if we do produce less of A, okay, the revenue falls, clearly. It's $25 a unit. And at the same time, on what I've written, if we produce less, the cost of materials will fall. Everything else will stay fixed. And so, what's going to change as we produce more or less is the selling price less the materials cost. But here with A and B, the selling price per unit, A is 25, B is 28. The materials, the only variable cost, 8 and 20. And therefore, in a sense, the contribution, selling price less variable costs, 17 for A, 8 for B. But we don't call it contribution because the standard definition includes all other variable costs. That we call the throughput. And given all the other costs we're assuming are fixed, however many we produce, we want to maximise this throughput for the limited number of hours available. And okay, on the face of it, A looks better at 17 a unit, B only 8. However, A takes twice as long to produce, and so we look at the throughput per hour. The hours per unit, A is 2, B is 1. And so the throughput we're generating per hour, or the return per factory hour, for A, 17 for 2 hours. Every hour used making A is therefore generating $8.50. B, 1 hour, well, every hour obviously is generating $8. And so of the two, as it turns out, A is the better, generating $8.50 an hour. B is second best at $8 an hour. And so how are we going to produce our production plan? A is better, so we'll produce as many A's as we possibly can. We can't produce more than demand, we won't sell them, so we'll produce 20,000 A's. Each one takes 2 hours, and so that uses 40,000 hours. Can't do any more A's, so go to the one that's next best, which is B. But here's where we hit the limit. With only 48,000 hours available, there's only 8,000 hours left to produce B. And at 1 hour a unit, we'll produce 8,000 B's. And if that's all we were asked, what's our actual production plan? There's the answer. 20,000 A's, 8,000 B's. This one carries on and says, what is the maximum profit? Well, first of all, on that production plan, how much profit will we make? Well, first of all, what will the total throughput be? A, 20,000 units. And ignoring the fixed costs, every unit generates $17. Total of 340,000. B, we're making 8,000 units, and again, ignoring any fixed costs, they're generating $8 a unit. Another 64,000, so a total of 404,000. However, of course, although that's the total throughput we'll be generating, the profit, we need to subtract the fixed costs. And here, listen carefully. If a question says the fixed costs are in total 300,000, then no argument. We simply subtract 300,000. Again, that 300,000 fixed cost will be the same, whatever the level of production. Here, we've not been told the total fixed costs. And remember, everything apart from materials we're regarding as fixed. In which case, we make one assumption, and I'll write it down. We assume that the original cost cards were produced before knowing of the limited hours. Now think about that for a second. If we added the costings, we didn't know there were going to be limited hours. Surely that means we'd have done our costings assuming we were going to meet full demand. I said at the very beginning, if hours weren't limited, you'd produce 20,000 A's, 10,000 B's. And so we're going to assume the cost cards were produced before knowing of limited hours, i.e. on basis of producing to meet full demand. And so when I did the cost cards, A and B, we thought we were going to produce 20,000 A's and 10,000 B's. We thought the fixed costs per unit for A, remember, everything's fixed apart from materials, so we thought the fixed costs per unit were going to be, there's 5 for labour, 7 for other variable, 3 for genuine fixed. So what's that? 15? So we thought it would be a total of 300,000 for A. And similarly for B. 10,000. We thought each unit would have these, what we now regard as fixed costs of 6, so a total of 60. So when we did the cost cards, we expected the total of these to be 360. Okay, we are producing a bit less, but by definition, fixed are fixed. And therefore, even though we're producing less, the fixed costs 360. Which leaves us with a maximum profit of 44,000. Can I repeat what I said at the beginning? If the question tells you a figure for total fixed costs, you use it. You only make the assumption I have if you're not told what total fixed costs are. Okay, not quite there yet, because part B says calculate and comment on the throughput accounting ratios. Now, you'll see the formula at the top. The throughput accounting ratio, the last formula listed, is the return per factory hour over the cost per factory hour and for each product we've already calculated the return per factory hour there, $8.50, $8. However, before we can actually calculate these ratios, the cost per factory hour are the total factory costs, the total fixed costs, as I've been defining them. And I keep repeating, but remember, only materials we're treating as variable, all other costs are fixed, divided by these limited hours. And so now I can finish it because we've already established the fixed costs are 360,000. The limited hours are, what were they? Sorry, the question, 48,000. And so the cost per factory hour, 360 over 48, is $7.50. And now we can get the throughput accounting ratio. For product A, if you look back, the return per factory hour was $8.50. The cost per factory hour is $7.50. And therefore, the ratio, if I leave it to 2 decimal places, is 1.13. Whereas for B, the return per factory hour was $8. Again, cost per factory hour $7.50. And so its ratio is 1.07. So there are the ratios themselves. As far as the comment and the interpretation of them, firstly, the higher the throughput accounting ratio, the better. And so we already knew A was the best, B was second best, and if there were several products, obviously we rank them. Now we don't actually need the ratio itself for that ranking. We already knew that A was best and B was second, but regardless. Secondly, though, and somewhat more importantly, surely if we're going to be profitable, it's costing us $7.50 for every hour we work in the factory. And so we want to make sure each of our products is generating more than $7.50. And therefore, we'd always aim for all products to have a throughput accounting ratio of more than 1. Which I hope makes sense. Okay, so that's the end of that chapter.